Biosecurity is important on all livestock farms, and the same thing applies to silage competitions, because we need to make sure there's no contamination of samples from one farm to the next, because some of the features that we're looking at depend on having a clean sample from that one farm with no possibility of contamination. So now we have to get up onto the silo, and we choose a location carefully. So we go 5 meters back from the front where the face is open, and we choose a point in the center, and then we have 3 sampling points. So we have 2 additional ones, 1 meter either side of the central point. Then we use the corer, and we have 3 sampling depths. So the first one is from the surface down to 10 centimeters, second one is from 10 to 20, and these samples are used to get an assessment of the dry matter loss. And then the third sample from the same point is from 20 down to 40 centimeters, and that is used for the analysis, the chemical analysis of the silage. It's used for aerobic stability, and also we can get a measure of the density from that as well. So we can't leave an open hole where we've taken a sample, so what we do, we take a silage from the face. We fill the hole with the silage from the face, we then compact it. And then we put salt over the top to prevent any microbial spoilage. And then we carefully reseal and tape the sheet on top. Then for each of the sampling points, the 3 samples are then put into the one bucket and carefully mixed. We also use a Penn State separator, and as you can see, it's a shaker box with different sized holes, so we can separate into 3 different fractions, and we can use this to determine the distribution of the particle size and also determine the chop length of the material. So we now take the pooled sample from the lowest sampling point, and we subsample that for chemical analysis. That's sent away. All the excess air is squeezed out, and then they're sealed. We also put a sample into a box which has got some holes in it, and we do a 5-day aerobic stability test by measuring any change in temperature, and then the final sample is used to assess the density of the silage itself.